Actually these topics should have been covered with or with the recorded lecture videos that I have provided you. Okay, last week pa yun. Okay, so although I am expecting that you are done with this by now, dahil you should have been you should be working on on your homeworks already dapat. Okay, but still I would like to go back with some of the ideas that or with some of these topics. In particular, I would like to breeze through articles 2.3, 2.4, tsaka 2.5. I mean 2.4 part A, part 1 at saka 2.4 part 2. Dalawa kasi. Okay, so I would like us to work on this first before we proceed. Okay. Napanood niyo na ba yung pinapapanood ko sa inyo? So, wala nag-respond. Okay. So, ganito. So nung yung previous the previous lesson to this topic is to this section, yung 2.3. Ang naunang topic diyan is a review of the Laplace Transform. Okay? So ang kailangan yung makuhang idea doon, dalawa. I need you to have to learn two ideas from that section. Okay? Yung first idea is yung tinatawag na differentiation property of Laplace transform. Okay, that's the first idea that I would have you learn from there. Okay, so and the second idea bago ko i-discuss ko na to. Okay, and the second idea is the idea of how to find or how the idea of how inverse Laplace transforms are determined. Okay. Kailangan natin yung idea nung inverse Laplace transform kasi ito yung gagamitin natin to actually find for the output signal. Okay, mamaya mas maintindihan niyo yung sinasabi ko. Pero what I have referred you to learn is that kailangan alam natin kung paano i-carry out itong operation ito for a given Laplace transform. Kung given kayo ng Laplace transform at gusto niyo hanapin yung function niya in the t domain, okay, then you carry out inverse Laplace transform. Okay, kumbaga kung meron kayong fs, okay, if you actually apply yung inverse Laplace transform operation there sa f of s na yan, then you'll get f of t. Okay, yung practice nito ng pagkuha nito is something that I would have you learn from section 2.2. Kasi gagamitin natin yan ng madalas in the future. Okay? So, yun. Now, balikan ko yung number 1. Yung number 1 is an idea that is widely used. Okay? Ito actually yung pinaka-basis ng lahat ng gagawin natin dito. This property of the Laplace transform, the differentiation property. Okay? Yan yung pinaka-basis na kung ano man yung what allows us to do these things the way they are done. Or the way they will be discussed here. Ito yung nagja-justify ito yung parang pinaka justification kung bakit pwede natin gawin yung mga methods na i-discuss natin. Okay? So ano ba yung differentiation property na yan? Okay, it states that the Laplace transform of the first derivative of a function. Okay? The Laplace transform of the first derivative of a function is s times f, okay, minus f of 0. Okay, yung f yung given function natin in t-domain whose Laplace transform is f. Okay, yung uppercase f. Okay, tapos yung f of 0 naman, yung f of 0 with this one being a lowercase is the value of the function f. Okay, this is the value of the function f at t equals 0. Okay, that's how we interpret that notation. Okay, maliwanag ba? Okay. Now, so this is the Laplace transform the first derivative. Yung second derivative naman, yung Laplace transform ng second derivative, okay, is s square times f, okay, minus s times f of 0, okay, minus f prime of 0. Okay, yung f prime of 0 naman is the derivative of f with respect to time. Okay? Sorry, that's f prime pa lang yan. Okay, that's the first derivative pa lang. Okay? Pati yan. So, yung f prime natin is basically the first derivative of f with respect to time. And yung f prime of 0 means, okay, it's the value of f prime, the value of the first derivative of the function at t equals 0. So I hope naiintindihan niyo itong mga notation na to. Okay? This notation is something that that is familiar with you. Okay? So ayun. Yun yung Laplace transform ng second derivative. Okay? Yung Laplace transform naman ng third derivative is essentially s cubed times f, okay, minus s square times f of 0, minus s times f prime of 0, minus f double prime of 0. Okay. Ngayon, nakakita ba kayo ng pattern dito? Nakikitaan ba natin 'to ng pattern? Okay. So, kung makikita niyo yung pattern na yan, diyan, okay, that actually leads to a longer equation for higher derivatives of the Laplace transform. Okay, pero naman, medyo obvious naman yung pattern na yan if you have to inspect this thing. Okay? Pero our work would actually be simplified more. Okay? If we make the assumption, and this is not a very unreasonable hindi naman unreasonable yung assumption na gagawin natin. If we make the assumption that your systems, every system that we will have to analyze in this course, are initially at rest. Okay? So, pag sinabi nyo ang system niyo are initially at rest, ibig sabihin nun, its response or its output signal, okay, yung output signal niya has a value of 0, okay, at t equals 0. And not only that, it's not the output signal itself, but all of its derivatives. So the output signal, okay, and all of its derivatives, okay, has a value of 0 at t equals 0. Okay, kumbaga, we collectively call this thing, okay, as initial conditions. Yung output signal at t equals 0 at saka yung derivatives of that output signal at t equals 0 are all initial conditions. Okay? So ngayon, ang gagawin natin is that since your system are assumed to be initially at rest, okay, then all of the initial values of that function, okay, is 0. So magre-reflect yan dito sa ginagawa natin ito, okay, by considering that all of this, okay, itong mga terms na to, okay, can be considered to be 0. Dahil nga i-assume natin that your system are at rest, your system is at rest. Okay? So therefore, yung ating ano lang to ha, in this particular case lang to ha, ito pa rin yung general definition ng ano ng differentiation property of your Laplace transform. Okay, ito pa rin yung general definition niya. Pero in our case, okay, in our particular case, we will have our system to be at rest, and therefore all of its initial conditions would be set to 0. And what is left of are this. So yung Laplace transform ngayon ng first derivative of the function is simply s of f, s times f. Okay? Yung Laplace transform ng f double prime is s squared times f. Okay, so tapos yung Laplace transform ng f triple prime equals s cubed times f. So yan yung gagamitin natin ngayon. Okay? In order for us to determine what is a transfer function. Okay? Naintindihan ba to? Okay, so sorry, nakatingin ako sa aso ko kasi naghahanap na naman siya ng maglalabas sa kanya. Anyway, so ayun. So ayun. Now, and this is something that you should have learned dun sa previous lesson nito. As per the video provided to you. Okay? But here's the thing. Ito rin kasi ginagamit natin para mag-solve differential equation. So, that should have been discussed dun sa video na yan. Okay. Now, going back to your system. Okay, going back to your system. Ito yung system ninyo. Okay? And that system is actually described by a differential equation. Okay? Sabi nga natin dun sa introduction natin to systems. Kung meron kayong system, okay, which is represented by a block. Tapos meron yung input na r of t. R is for reference. Okay. So this is called the reference input. And the output is C, designated as C of t. Okay. C is for control variable. So that makes it your output. Okay. Again, itong t na to are independent variables of those functions. Ibig sabihin that your R, okay, depends on time, as well as your C, okay, depends on time. Okay, so I can simply write R of t as R, okay, and C of t as C. Okay, pero knowing that this is R and this is C, lowercase c ito, okay, this actually is designated in functional form, okay, as C of t. Ito yung functional form niya. Ito, ang sinusunod ko dito, yung function name lang. Okay, or yung variable that represents the function. Okay, ito namang R natin dito is designated as in functional form or in functional notation, this is R of t. Pero I can write it simply as R. Okay? And in the same manner, pag ito, kinuha ko yung Laplace transform ng R, okay, I can write it as the uppercase R. Okay, pero pwede ko rin siyang isulat as R of S. Again, yung S dito is the independent variable now in the Laplace transform or in the Laplace domain. So in the Laplace domain, our independent variable is S. Okay? So therefore, pwede ko siyang isulat as R of S. Pero to simplify matters and to not make matters more confusing by to make matters not more confusing by writing less letters and less symbols, then we can sometimes use R. Okay? Same thing with C. Okay? Your control variable. Your control variable has a Laplace transform. Pag kinuha ko yung Laplace transform ng C, that can be written as the uppercase C. Okay? Medyo maging mindful lang kayo kapag nagsusulat tayo dito kasi minsan dahil walang rule, walang lines yung actually pwede mo lagyan ito ng lines pero dahil wala siyang lines ngayon, I may have difficulty differentiating yung uppercase C at saka yung lowercase c ko. Okay, so be mindful na lang of what I say. Kung ang sinusulat ko ay uppercase C or lowercase C. Okay, para kapag nire-review niyo itong notes na 'to, maaalala niyo na, this is lowercase c and this is uppercase C. Okay? So, ayun. Ngayon, again, the Laplace transform of C of t o C is the uppercase C. Okay? And or can be written also as C of S instead. Ito yung parang functional notation naman niya. Okay, pero kapag gusto natin ng medyo naka-shortcut ng konti, let's just simply use the uppercase C to denote the Laplace transform of this signet. Okay, so going back, yung system natin having an input R of t and output C of t. Okay. The relationship between C of t and R of t, okay, is defined by a differential equation. Okay, ma-define yung differential equation, which is basically ito. Ito yung differential equation that describes the relationship between the two. Okay? Ang problema dyan is, una, if this is a very complex system, then this differential equation tends to be especially this side. Kung masyadong complex yung system niyo, okay? That side may actually contain really high orders of derivatives. And if that is if your system has that high order of system, finding a solution for that system might prove to be mathematically challenging. Okay, yun ang problema doon. Okay, ito kasi refers to your input, and yung input naman natin can be just a limited can have a limited expression kasi hindi naman tayo gumagamit ng fancy inputs. Mga simpleng step signal, mga ganoon naman yung ginagamit natin. Sinusoidal signal, which has a simple is represented by a differential equation that is minsan nga hindi pa differential equation eh. Minsan pwedeng sin of omega t lang yan. Okay, so wala pa derivative yan. Okay. And komplikado na yan in that case. Okay, so this right side is will not most of the time contain very high order of derivatives. Pero ito yung concern, yung left side. Kasi yung left side sigurado meron derivative siya. Okay, and if the system is really that complicated, then that may contain very high orders of derivatives. And that is why ito medyo mahirap i-solve ito ng looking at it as a differential equation. So what we do is we actually try to obtain the Laplace transform of that equation. Okay, pwede natin hanapin yung Laplace transform niya. Okay. By having so tingnan natin yung first term. Okay, look at the first term. Okay, by linearity, itong an, may set aside natin yan. Kung kukunin natin yung Laplace transform ng first term, okay, yung an, masa-set aside natin yan. Okay? And then we proceed now with getting the Laplace transform of this derivative. So we're looking for the Laplace transform of the nth derivative of C. Kukunin natin yung Laplace transform ng nth derivative of C. Okay, paano natin kukunin yun? Kung titignan nyo yung pattern dito, paano kaya siya? Kunin yung Laplace transform ng nth derivative ng C. Sundan natin yung pattern dito. Anyone?
Look lang. Ipag-look lang.
Anyone?
Ano daw?
Kung natin yung Laplace transform ng nth derivative ng C. Ito, third derivative to ng F. Ito yung Laplace transform niya. Ito yung second derivative ng f. Ito yung Laplace transform niya. Ito yung first derivative ng f. Ngayon, kung kukunin natin yung Laplace transform ng nth derivative ng C, paano kaya natin siya isusulat? So, magsisimula yan syempre sa S. Ano dapat yung exponent ng S? Kasi makita niyo dito, ang exponent ng S dito ay 3. Okay?
Po, sir.
Ha? Anong exponent dapat ng S dito? Nth derivative to ha. Yung kapag yung superscript ng function niyo is enclosed in a parenthesis. Nth derivative 'yon. Iba yan sa c raised to n. Yung n dito is power. Okay? Pag in-enclose yan sa parenthesis, that's derivative. So, meaning this is nth derivative. Okay. So, again, kung third derivative ito, yung exponent ng s dito is 3. Kung ang derivative nyo dito is 2, second derivative, yung exponent ng s nyo dito, yung power ng s nyo dito is 2. So, how about here? Kung nth derivative to, ano dapat ang exponent dito ng s? Anyone? Kain mo na ako konti. Nagutom na kayo. Yup. N. Okay. Very good. So, yung exponent ng n. Okay. And then, we multiply by the, ano multiply sa kanya? Dito, minultiply natin to by f. Ano ba yung f na uppercase? So, multiply ng C. Pero in particular, we will use the uppercase C. Kasi we're referring to the Laplace transform. Itong sing f na to na uppercase is the Laplace transform of f. Okay, yung function na nandito. Ito kasi, derivative siya ng function. Yung f triple prime na yan is the derivative of the function. We still have the function f na pinagsisimula nun. So we get the Laplace transform of f, which is the uppercase f. Okay, yun yung mumultiply sa s cube. Okay? In this case, c naman yung C naman yung function natin. Okay? So we multiply that with the Laplace transform of c. Okay? So, tapos minus yan ng mga terms that pertains to the initial conditions. Okay? That pertains to the initial conditions. To the initial conditions, mali yung expression ko. Ulit. This is minus summation to ng S basta merong expression yan dito that pertains to the initial conditions. Okay. But then again, sabi nga natin, in this particular case that we are considering, we will consider all your initial conditions to be 0. So therefore, lahat ng terms na to magva-vanish. Magiging 0 na lang yan. Okay, so that said, the Laplace transform ngayon ng nito, okay, is simply s raised to n times c. Okay, so ngayon kung kukumpletuhin natin yung Laplace transform niya. Okay, if we have to complete the Laplace transform of that one. Okay, so we will have s raised to n times c. Okay, ito yung Laplace transform nung derivative na yun. Okay, and then continuing, paki-check na lang kung tatama ako. This is a sub n minus 1 times s raised to n minus 1 times c. Again, uppercase yan. Okay, and then hanggang makarating kayo dun sa dulong term na to, which has the Laplace transform a sub 0 times c. Okay? Naintindihan mo to? Okay, I'll continue na lang. I'm not really sure kung delay yung natin o talagang wala sumasagot sa inyo. Okay, so on the right side, taking the Laplace transform of this one, we will have b sub m times, this is s raised to m times r. Okay, r here pertains to the Laplace transform of r of t. So r of s yan actually. Plus, mali pala. Dapat pala nilagay ko na sa baba. Ulit. This is equal to b sub m, okay, s raised to m times r plus b sub m minus 1 times s raised to m minus 1 times r, okay, and so on until dun sa last term, okay, whose Laplace transform is simply p sub 0 times r. Okay? Now, what you need to notice about this, okay, is what you need to notice about this is that yung right side ay yung left side, lahat ng terms sa left side contains the function c. Okay, it contains the function c. Lahat yan magkakaroon yan ng c. Kahit na tingnan niyo yung kasunod nito. Okay, at o kaya yung una dito, which is a sub 1 times the first derivative of c with respect to t. Na kapag kinuha nyo yung Laplace transform niyan, should have been a sub 1 times s times c. Yan yung term preceding this term. Okay? So makikita nyo, meron pa rin yung function na c. So I can actually factor that that function out of this polynomial, producing a sub n times s raised to n plus a sub n minus 1 s raised to n minus 1 plus, okay, until doon sa dulong term which is a sub 0, and then all of those are multiplied by the function c. Okay? So, ayun. On the right side naman, ganun din. Kaya lang, all the terms naman contain r. So, if I actually factor that function r, okay, out of this, we will have b sub m s raised to m plus b sub m minus 1 times s raised to m minus 1 until the last term, which is b sub 0. Okay, and that should give you r as the common term for all of these terms. I mean, the common factor for all of these terms. Now, what I want to do after this is to actually solve the ratio. Okay. I would like to solve the ratio I would like to solve the ratio C over R. Okay, gusto ko i-solve yung ratio na C over R na yan. Okay, so since this is C, tapos ito yung R. Okay. Basically, sabi natin yung C can also be written as CS in its functional form. So, I'd like to solve CS over RS. So, yung R naman dito is RS in functional form. Ayun. Yung R dito is RS in functional form. So, yung C dito is C of S in functional form. So, I would like to solve the ratio C of S over R of S. And that should give you C ito, R ito. So, kung ito madidivide dito, then itong polynomial na to, mapupunta sa denominator nito. Okay, and that basically is B sub M S raised to M plus B sub M minus 1 S raised to M minus 1 until P sub 0, okay, divided by A sub n S raised to n plus A sub n minus 1 S raised to n minus 1 until the last term, which is A sub 0. Now, this is what we are trying to obtain. Okay. Number one, this ratio, the ratio of these two polynomials, or basically the ratio of C over R, pertains to what we call the transfer function. So ito yung tinatawag natin ngayong transfer function. Okay? Now, if you observe more closely, yung G of S ninyo is C of S over R of S. Again, kung i-review natin yung mga terminologies na ginagamit natin. Okay. C of S is actually the transform of output. Okay? The transform of the output of your system. The output being C of T. The output being C of T. Okay? While RS, or R of S, sorry, is the transform of the input. Your input signal being R of T. Okay? Yun. So, kung titingnan nyo itong block diagram na din-drawing ko kanina na ilipat nga natin yan. Paano ba to? Yan. Lipat natin siya dito. Yan. So, first time kong ginawa yun. So, yung sinasabi natin kanina tungkol sa system niyo is that since R of T at saka C of T is described by a differential equation, this is getting really, this is tough to solve. Especially if your differential equation is contains very high ordered derivatives. Okay. So, ang alternative natin is to use Laplace transform. Okay? But which requires us to find the Laplace transform of R of T, which is R of S nga. So, sinasabi natin kanina pa. And the Laplace transform of C of T, okay, which is C of S. Okay? Now, this system now would be described by the transfer function G of S. Yung ilalagay natin sa loob nung block diagram niyo. Okay? So we can only conveniently place this transfer function sa loob ng block diagram niyo. Kasi this is more more compact in form. Ikumpara niyo yan dito. Okay, na differential equation. Okay. And furthermore, if you take a good look at this relationship, kung titingnan niyo itong relationship na to, okay, I can actually solve C of S out of that. Okay, I can actually solve C of S out of that as the product R times G. Okay? So, ang sinasabi nito is that, pag pala yung Laplace transform ng input ko, ay minultiply ko sa transfer function ng system ko. Okay? I can obtain the Laplace transform of the output. Okay? And this is how intuitive this transfer function is. Itong formula na to can actually be read from this block diagram. Mababasa nyo yan dito. Okay? Kita nyo yan. Kasi kapag binasa nyo yung block diagram nyo from here to here, makikita nyo na parang ang impression is that para makuha nyo itong output na to, kailangan nyo i-multiply itong signal at saka itong system para makuha nyo yung transform ng output nyo. But then again, I would like to point out that this C is the transform of the output. And it is not the output itself. Okay? C of S is the transform of the output. Okay? C of S is the transform of the output. Okay? C of T is the output, or what we call the response signal. And if you're asked to find the output of a system, then the problem actually asks to find C of t. Okay? Pero ano ba ang relationship between C of S at C of t? We just have to remember that C of t is the inverse Laplace transform of C of S. Okay? And that is why, sabi ko kanina sa umpisa nito, that the second idea that you need to obtain dun sa previous lesson to this one, okay, should be to find inverse Laplace transforms. Dahil there are times that we need to find the output signal, okay, but the transform of the output is easier to obtain than the output signal itself. Especially kung ang titingnan natin is yung differential equation na magde-describe ng system. Okay? So in that case, yun na nga, kailangan alam natin kung paano mag-evaluate ng inverse Laplace transforms. Kasi kapag hindi, mahirapan tayong kunin tong city na to. Okay? Naintindihan ba yan? Okay, so let us try to apply that idea here. Okay, let's try to apply that idea here. The problem is that we are asked to find the transfer function of the system that is represented by this differential equation. Okay, so your system is described by that equation. Okay, and then assuming zero initial conditions, we wish to find the system response to a step input. Okay, so given naman yung R of t, ang pinapahanap sa atin is system response. Okay, system response natin again is C of t. Yun ang maahanap natin dyan, C of t. Okay, and some special notes. Yung input na U of t, okay, that input U of t is called the step signal. Okay? So, yung step signal na yan, essentially is defined, mathematically is defined as 1 when time is positive or when t is positive. Okay, and 0 when t is negative. Okay, yan yung mathematical definition ng U of t. Pero kung i-graph natin siya, ganito itsura niya. Saglit na. Close natin ito. Okay, so step signal, no? We can graph yung 1/2 nung signal niyo, yung first definition niya, which is 1, okay, when t is positive, okay, when t is greater than or equal to 0. So, nakita niyo yung red line. That's the 1/2 of the definition. And the other half of the definition, okay, is 0, okay, for t t less than 0. Ay, sorry, less than pala. Greater than nilagay ko. Less than 0. Okay, as you can see here, okay, screenshot natin to. Yan, screenshot natin. Yan, sakto. Okay. So as you can see here, zoom in tayo konti. Again, if I may, ang u of t ninyo, okay, is defined as the one half of the definition is that u of t is 1 if the value of your t, okay, the time element is greater than or equal to 0 or for positive t, okay. And then the other half of the definition is that it is 0 for t less than 0 for negative values of t. Okay. So, itong step signal to, this is called a step signal. Okay. Is actually a very common signal that we use in the analysis of systems. Okay. For one thing, this signal represents a constant input to your system. Okay. A constant input that is only activated at t equals 0. So, magkakaroon ka lang ng signal or magkakaroon ka lang ng constant function at the moment t equals 0. And this very definition of your step signal actually models what we call a switching action. Okay? Parang sa unang part ng system, there is no input into your system. So 0 yung value ng signal niyo. Pero at the moment na i-operate natin yung system, we usually term that part as time 0. Okay, at time 0, the moment that we open we operate that system, then your input switches from 0 to 1. Kulang yung 0 to 1. Okay? So, yung ito is models a switching action. Okay? And then from there, magkakaroon ng constant input yung system mo. So, you now have a constant input. Ito yung point na yung u of t ninyo equals 1 when t is positive. While ang u of t nyo is 0 when t is negative. Okay? So I hope this thing about step signal is something that you understand kasi yun nga importante ito in a manner that madalas natin yung gagamitin. Okay? In fact, we will define, okay? Magde-define tayo ng isang phrase that is to be used very often. Okay? Step response. Okay? When you say step response, it means the response. And again, when you say response, itong response word itself, it means output. Okay? So the step response is the response or the output of the system for a step input. Okay? If your input is a step signal, okay, then its output is the step response. Okay? So that is why kapag binanggit ng problem that find the step response of this system, okay? You would know that the input for that problem is a step input. Kasi yung step response yung hinahanap niyo. Okay? So I hope this term is clear and is something na tatandaan nyo all throughout kasi yun nga, madalas natin gagamitin yung term na yan. Okay. Now, proceeding. Okay. Again, given tayo ng differential equation description ng system niyo, which is the derivative of c with respect to time plus 2c equals r. Okay? I drop the of t notation. Okay. Now, what we want to do para mahanap natin yung transfer function is we obtain the Laplace transform of this equation. Okay, assuming 0 initial conditions. Okay? So, in that case, yung Laplace transform ng first derivative of c is essentially s times c. C here is an uppercase c. Okay, kasi nga Laplace transform na siya. Plus 2c, okay, equals Laplace transform ng r is ng lowercase r is the function uppercase r. or essentially R of S. Okay, so tandaan na ito is essentially C of S. Okay, ito naman, essentially R of S. Yung of S na yan, dinadrop ko lang muna kasi part siya ng solution eh. Mamaya ko na lang ilalagay kapag ka medyo malinis ng tingnan yung malinis na tingnan yung equation ko. Okay? So, ayun. Now, again, as we have done in the previous in the derivation, okay? Tingnan natin, makikita natin that the left side of that equation after taking the Laplace transform, okay, contains all the terms here contains the function c. So therefore they can be factored out. Pwede natin siyang i-factor out there. That gives us s plus 2 times c, okay, equals the right side, which is r. And if you're looking for the transfer function, okay, again, nabanggit natin kanina that this transfer function is the ratio c of s over r of s. So ito yun, c over r. And if we actually take this ratio from here, we will have 1 over s plus 2. So that should give you the transfer function that the problem requires us to find. Okay? Maliwanag ba? Now, we proceed with finding the step response. Okay? Again, response is C or output is C. So therefore, kung meron tayong system, okay, whose transfer function is 1 over s plus 2. Okay? And meron siyang input na u of t. Okay, na meron siyang input na u of t. Okay? Ang Laplace transform ng R na yan ay R of S. Okay? And if we actually, mamaya lang. Ang Laplace transform ng R na yan is R of S. Okay? While having an input of u of t, itong system nyo na to, described by this transfer function, would produce an output, which is something that we are looking for. Yan yung hinahanap natin. Okay? But just remember lang that the C of t has the transfer function C of S. Okay? Meron yung transfer function ng C of S. Now again, if you can again recall, okay, we can actually find C of S. Okay? Again, reading from this, okay, that is R times 1 over S plus 2. Times, So R times 1 over S plus 2 gives us the transform of the output. Ang question na lang dito is what is R? Kasi ang alam lang natin is the time domain R, okay, which is U of t. Okay? Pero yung R na to, yung uppercase R na to, is the Laplace transform of this one. So therefore, we have to find the Laplace transform of U of t. Okay? We should find the Laplace transform of U of t. Ano nga ba ang Laplace transform ng U of t? May idea ba kayo? Kung ano ang Laplace transform ng U of t? Ayun. Kung wala, nasa ano yan? Nasa previous discussion. Andito yan sa table 2.1. Okay? But just a reminder, yung U of t ninyo, tatandaan din natin to kasi sa ibang expression lalabas yung U of t. Okay, lalabas yung U of t. Pero sa iba pang expression, okay, lalabas lang yan na 1. Okay, lalabas lang yan na 1. Okay, so therefore, kasi nga ganito kasi yun. Ang assumption kasi nga natin sa mga system natin is that it is a system that is right-sided. That is, all of its action takes place after t0 or after time 0. So therefore, lahat ng signal na ina-analyze natin is nasa right side. Okay? O nandito sa side na to ng natin, ng graph natin. Okay, nandito sa side na to ng graph natin. Dito. After T0. Okay. So therefore, kung ito lang talaga kung yung right side lang talaga titignan natin, then essentially u of t equals 1. Okay? So that is why sa ibang expression lalabas din yung u of t, yung step signal mismo, yung step signal notation, u of t. Pero in other problems or in other things, lalabas diyan 1 lang. Okay? Again, that stems from the fact that essentially at this side of the graph na titingnan natin, in which all of the action of your control systems applies or happens. Okay? U of t equals 1. Okay? So therefore, kung titingnan natin yung yung ating table dito. Okay? Kung titingnan natin yung mabuti, ang Laplace transform ng u of t is 1 over s. Okay, the Laplace transform of u of t is 1 over s. And so is the Laplace transform of 1 is also 1 over s. Kasi nga, essentially, equal to dalawang to. Okay? So, ibig sabihin ngayon, going back dun sa ginagawa natin, kung kukunin natin yung Laplace transform, ito kasi yung ito yung R of t nyo, which is u of t. Yung R of t nyo is given as u of t. And kailangan natin kunin ito, yung R of s. Okay? So which means we have to obtain the Laplace transform of this. And therefore, R of s equals 1 over s. Okay? So this is now then equal to 1 over s times 1 over s plus 2. So ba? Ang layo niya masyado eh. So that is 1 over s plus 2. So ba, ang haba. Okay? Naintindihan ba to? Okay. Again, i-recall natin, kasi may expression na ako ng C of S eh. Okay. And that essentially is the transform of the output. This 1 over S times S plus 2 is essentially the transform of the output. Okay? But what the problem needs to solve, what the problem requires us to solve, is the output itself. That is, the problem wants us to determine what is C of t. Yan yung pinapahanap sa atin. So therefore, para mahanap ko yung C of t, kailangan kong kunin yung inverse Laplace transform of C of s. Binanggit ko rin yan kanina. Okay, kung kukunin natin talaga yung actual response or actual output, okay, the step response. Again, step response siya kasi yung input nyo, yung step signal. Kung input nyo hindi step signal, hindi step response ang tawag natin dito ha. Okay. So ayun. So para makuha natin yung system response or yung step response, okay. Essentially we have to obtain the inverse Laplace transform of C of S. Okay. And for us to do that, kung titingnan natin yung ating given na C of S or yung nakuha nating C of S pala. Okay. That's 1 over S times S plus 2. And in this case, since rational function siya in S, para makuha natin, ang first step para makuha natin yung inverse Laplace transform to is to first decompose this into partial fraction. Okay, so ikukunin natin yung partial fraction decomposition of this this function, which essentially is A over S plus B over S plus 2. Naalala ba yung partial fraction decomposition na lesson nyo before? Kung hindi na, kailangan yung reviewin yun na kasi kasama yun sa ano, kasama yun sa, actually, yun yung skill na kailangan sa ano, sa pagkuha ng inverse Laplace transform. Okay, so that is really important sa ano, sa atin, para sa atin. Kasi we sometimes need to solve for the output. Okay, so therefore, kailangan meron tayo ng skill na yan. Okay, now, so kung marirecall nyo, yun nga, ito siya. Now, what we need to do now is to solve for A and B. Okay, kaya tayo ma-solve yung A at B. So, kung maaalala nyo ulit, meron kayong various methods of solving this. Okay. Technical, ang tawag natin diyan sa ang tawag natin diyan sa A at sa B na yan, residue. Okay, tawag natin sa A at sa B na yan, residues. Ano yan? A and B are called residues. Okay. So, we need to solve for A at B. And again, kung i-recall niyo yung lesson niyo sa partial fraction decomposition, meron siguro tinuro sa inyo yung technique para ma-solve yung mga residues na yan. Okay? Actually, meron din ako sariling technique na ginagamit ko. Okay? Which, essentially, ang tawag ko doon is cover-up method. Ang problema lang, hindi ko maipapakita yung cover-up method kasi that cover-up method actually involves me covering up the fraction. Okay, physically Kaya lang, since nasa ganitong setting tayo, hindi ko pwedeng itakpan yung screen ko kasi hindi nyo naman makikita. Okay, pero ganito yung ito yung essential idea about cover-up method. Okay. Tingnan niyo yung we're solving for A. Okay, we're solving for A. If we're solving for A, tingnan niyo yung denominator ng A sa first fraction. Okay? So, nakita nyo, ang denominator ng A dito sa fraction na to ay S. Okay? Ngayon, kung S itong denominator ng A dito, yun yung tatakpan nyo dito sa left side. Ibig sabihin, tatanggalin nyo yung factor nung S dito. Okay, so essentially, ang matitira dyan is yung 1 over S plus 2. So, we can now solve for A as 1 over S plus 2. Kaya lang yung S, may papalit tayong value sa S. Okay? May papalit tayong value dyan. Ano yung ipapalit natin? Okay. Again, tingnan natin yung pinanggalingan ng A, which is A over S. Okay? Tapos, tingnan ulit natin yung denominator niya, which again, in this case, S nga siya. Ang gagawin natin dyan is that yung denominator nito, i-equate natin sa 0. And then, isa-solve natin for S. Kung ano man yung masasolve natin constant, yun yung ilalagay natin dyan. So, in this case, yung S natin solves to 0. So, therefore, this becomes S equals 0. Nagets yung method. Okay, kapag kung sa klase yan, kung nasa face-to-face tayo, ang ginawa ko niya sa whiteboard, ito, tinakpan ko yan. Kaya tawag dyan, cover-up method. Kasi ito na lang yung may iwan. Okay, so ito yung may iwan, ito yung gagamitin ko para ma-solve yung A. Tapos, kukunin ko nga ito. Okay. Ang tawag nyo dito, basically, ay pole. So, S equals 0 equals a pole. Okay, tandaan nyo yung term na yan. Kasi yung term na yan, gagamitin natin yan doon sa susunod pang mga lesson. So, tawag natin dyan sa S equals 0 yung pole. Okay? Maliwanag? Tanggalin natin yung cover ng A. Tanggalin natin yung cover nung S dito. Ayan. Pwede pala yun Ayun, naisip ko na kung paano gagawin yung cover-up method. Tignan nyo to. Okay. Paano naman yung B? Okay. How do we solve for B? Again, tignan nyo sa partial fraction decomposition yung denominator ng B. Gawin natin, i-cover natin yung B. Ayan, i-cover natin siya. Ano iwan? Yung S na lang, di ba? So, 1 over S na lang yung gagamit natin para ma-solve yung B. Pero mayroon tayong isa-substitute dun sa S na yan. Okay? So, ano yung isa-substitute natin dito? Again, tingnan natin tong decomposition na to. So, that's B over S plus 2. Okay? Then, kunin nyo yung denominator. I-equate nyo sa 0. Tapos, isolve nyo yan sa S. Okay? So, nakuha natin tong pole na to. Again, tawag dyan pole. Okay, this is another pole. Ibig sabihin, yung system nyo, meron, yung partial fraction decomposition nyo, meron dalawang poles. S equals 0, tsaka x equals negative 2. Okay, so in this case, itong s equals negative 2 to, ito yung gagamitin natin to solve for b. Okay, so tanggalin na natin to. Ay, natanggalin yung ano. Yun nga iniiwasan ko eh. Hindi pa rin pala maganda yung plano ko. Ayan, so okay, ibalik ko na lang. So that's how we solve for a and b. Okay. And then, doing the necessary substitution, we find that a is 1/2. Okay, verify nyo na lang ha. A is 1/2 and b is negative 1/2. Okay? So, with that in mind, we can now rewrite C. Okay? Tandaan nyo, ito yung C eh. 1 over S times S plus 2. So, pwede ko nga yung i-rewrite yung C. Okay, we can rewrite C as C of S, I mean. As, since ito ay A over S plus B over S plus 2. Ay nalaman ko nga yun na yung A ko ay 1/2, tapos yung B ko ay negative 1/2. So now, we can rewrite C as 1/2 over S, okay, minus 1/2 over S plus 2. Okay? Which now lends us a way para makuha natin yung inverse Laplace transform niya na C of t. Okay. And again, this is something that you should have learned to do in the recording for the previous lesson. Okay? Yung inverse Laplace transform nito is found by isolating first this constant. So 1/2. Tapos ang maiiwan kasi pag na-isolate ko na yung 1/2 is 1 over S. Okay, tingnan niyo mabuti ha. Yung maiiwan diyan is 1 over S. Okay? So what I need to find now out is what is the inverse Laplace of 1 over S. And pag maghahanap kayo niyan, okay, pag maghahanap kayo niyan, again, refer back to the table. Hanapin natin yung function na merong Laplace transform na 1 over S. So, nandito siya. Ayan. So, as you can see, okay, ito yung function or ito yung 1 over S. So, ibig sabihin, ito yung Laplace transform na 1 over S. Ang tanong is, ano yung f of t? Okay. Na ang Laplace transform ay 1 over S. So, dito, nakikita nyo, that's u of t. Okay. Pero again, yung u of t na yan, equal din yan sa 1. Okay. Equal, that u of t is also equal to 1. So, therefore, instead of actually saying that the inverse Laplace transform, the inverse Laplace transform of 1 over S is u of t. Alternatively, I can also say that the inverse Laplace transform of 1 over S is simply 1. So therefore, yun yung ilalagay ko dito. I-multiply ko yan sa 1/2. Again, ginawa ko sa 1/2 na to, sinet aside ko siya para maiwan tong 1 over S. Tapos ito yung hinanapan ko ng inverse Laplace transform. And that turns out to be 1. So therefore, this is 1/2 times 1. Okay? Maliwanag sana yun sa inyo. Okay. So how about the other term? Again, iset aside natin itong coefficient na to. So that's 1/2. Okay. Ang may iwan dyan is 1 over S plus 2. Okay? And if we actually take the inverse of that, again, we're looking for a function na kapag nilaplace transform ko, ito yung lalabas, 1 over S plus 2. So let's look at the table. Okay, let's look at the table and find that we have here 1 over S plus A as a function under f of S. Ang hinahanap natin is yung function na ang Laplace transform ay 1 over S plus 2. So in this case, kung ikukumpara ko ito at saka ito, yung nandito sa table at saka yung given sa akin, I can say that A equals 2. Pareho naman sila ng forma, di ba? 1 over S plus 2, 1 over S plus 3. Pareho ng forma yan. So actually, pareho talaga siya. Okay, it's just that in this particular case, A equals 2. Okay, and ang inverse nun, ang inverse na Laplace transform nun, is e raised to negative at times u of t. Okay. Again, yung u of t natin can be considered as 1. So we can simply say that this is e raised to negative at. Okay, in fact, ito, pwede itong t lang. Ito, t raised to n. Ito, sin omega t. Ito, cosine omega t. Pwede namang isort na ganyan na lang. Wala na yung u of t. Okay? So, therefore, in this case, ito yung nahanap ko, e raised to negative at. But in this case, a equals 2. Okay, so therefore, yung inverse nito is simply e raised to negative 2t. Okay? Oh. Naintindihan kaya yun? Okay. Sorry, kumakain ako. So, balikan natin yung ginagawa natin. So, ang inverse nito, yung inverse nito is found to be e raised to negative 2t. So, therefore, yung i-multiply ko dito, kasi itong 1/2, sinentaside ko muna yan. Ito nga yung 1/2 na yan. Pero yung inverse nito turns out to be e raised to negative 2t. So, therefore, your signal CT or your step response is 1/2 minus 1/2 e raised to negative 2t. Okay, tingnan natin yung response. Okay, now since yung system natin wala namang binigay kung ano siya. Hindi naman sinabi kung ano yung system natin. So hindi natin alam kung anong quantity ang nire-represent ng output. We don't know what quantity does the output represent. Okay, so therefore, wala tayong unit na may lalagay dito sa C of t. Pero if you know what quantity is this, lalagyan natin siya ng unit. For example, if this C of t is halimbawa speed. Sinabi na yung output nyo is speed. Then we might as well place meters per second there. Okay? So para fully ma-describe natin yung sagot natin. Okay. So here, merong ginawang model dito. Papaspasan ko lang itong part na to. Alam ko pinaliwanag ko din naman to sa video. So i-turn over ko kayo doon sa video for an explanation of what is this. Okay, pero basically ito, kinuha ito from this model. Na-derive tong diagram na to using this model. By the way, ginamit ko dito is yung XCOS tool of Scilab. Okay, XCOS tool of Scilab ang ginagamit dito. Equivalent to ng Simulink na kasama ng MATLAB. So, if you have already installed Simulink and MATLAB and Simulink for this course, pwede niyo gawin itong itong diagram na to sa MATLAB. Yun nga lang, iba lang yung mga symbols na gagamitin niyo. For example, ito, this is actually a summing block. So baka iba siya sa malamang iba siya sa Simulink. Okay, this is an integrator. Okay, this is gain. Okay, this is step signal. And this is a scope. Okay, and kung gagamit kayo ng Simulink, hindi nyo kailangan itong clock. XCOS kasi yung nangangailangan ng clock eh. Yung Simulink kasi may internal clock na siya. So lahat ng components niya dito is run by the same clock. And ito, hindi ko alam kasi kung anong idea ng XCOS, bakit may separate pa silang clocking. Okay, para sa scope. So ayun, kung gagawin ito sa Simulink, hanapin niyo tong mga elements na yan doon para ma-build niyo siya. Okay. Ngayon, ang gusto ko kasi gawin ganito. Ikukumpara ko yung output nito, okay, using this model. Okay? And yung output niya based dito sa sa solution natin. Okay, kumbaga, gusto kong patunayan na whether you use the model or you use this, you'll have the same graph, which turns out to be true. Ito yung graph nung ito yung graph nung yung graph ng response This is the response. Okay. This is the response produced by this model. Okay. And this is the response from C of t, which is yun nga, 1/2 minus 1/2 e raised to negative 2t. Green up ko lang tong expression na to para makuha tong graph na to. And they may not may mahirap nga lang talaga siya ikumpara kasi hindi siya they're not contained on the same graph. So therefore, kasi ang problema rin kasi minsan natin ng ibang students is that pag nakakita kasi ng graph, okay, when they see graph, tapos the graph seems to be similar, sinasabi nila kagad na pareho siya. That's the outright conclusion. Basta makita nila na yung shape ng graph, ganyan. Tapos yung shape dito, ganyan. Okay, pareho yung shape. Okay, the student would suddenly jump off the conclusion that the two graphs are equivalent. Okay? Mind you, tignan nyo muna yung axis. Kasi baka mamaya, itong axis nyo, naka-scale pala sa 10 raised to 4. Tapos ito, hindi. Okay? Tapos itong isang ito, hindi naman. So, anong ibig sabihin nun? Ibig sabihin nun kasi, magkaiba sila ng value. So, hindi sila pareho. For one thing, ito, nakita nyo, naging constant na siya dito, no? This became a constant now. Okay? So, kung constant na yan, we call this the settling value. Okay? We call this state of your system. We call this, this part of the response as the steady state. Okay? This is where this is when the system settles in a form that is similar but not equal. Iba yung similar, iba yung equal. Okay? That is similar to to the form of the input. Okay? Ang control system nyo kasi dapat ang mangyari dyan is that eventually, kung ano yung behavior ng input nyo, dapat yun din yung maging steady state behavior ng output niyo. Okay? Kasi doon yung masasabi na nakokontrol nyo yung system. Okay, if the system has an input na constant, pero ang output niya ay oscillating, hindi nyo nakokontrol yung system. You're not controlling the system. Okay, you're not exactly controlling the system. Pero meron mga applications na ganyan na constant yung input pero yung output oscillating. Okay? May mga ganyang application. Pero most of them are not really control systems. Okay? Essentially, ang isang control system, kapag meron siyang input na constant, okay, eventually, magsasettle yan sa constant na steady state. Kung ang input mo sa system ay ramp, ibig sabihin increasing, okay, eventually, kahit ano pa nangyayari sa unahan yan, eventually, magiging ramp din yung output mo. And that is when you say that your system is controlled. Okay, that is the time that we consider that system to be a control system. Okay? Maliwanag ba yan? So, tingnan nga natin. Ayun, babalikan ko pala yung argument ko dito, no? So, kung ito yung steady state, ibig sabihin, meron siyang settling value. It settles on a value. Kasi nga, constant siya. Okay, tandaan nyo tama yung, controlled yung output natin. Kasi kung makikita nyo, ito nga yung input natin. Constant. Okay? So, therefore, yung system nyo, magsasettle din sa constant value. Kaya controlled yung natin. Controlled yung system natin. Okay? So, pero makikita nyo dito na ang settling value niya, nagsisettle siya sa 0.5. 1/2. Ito. Okay? Ngayon, ito, nagsisettle din to sa actually sa 0.5 Okay? Pero kung itong scale nyo dito, naka 10 raised to 4, that means ang settling value nyo is 0.5 times 10 raised to 4. Or basically, that's 5 times 10 raised to 3. 5,000 yan. Kumpara nyo yan sa output na to, na 0.5 lang. So, pareho ba silang dalawa? Hindi. Kasi magkaiba sila ng value. Kaya huwag kayong titingin kaagad na ano. Huwag kayong titingin, pag tumingin kayo ng graph na magkahiwalay. Tapos, nakita nyo na pareho siya ng shape. Okay. Tingnan nyo muna yung ibang parte ng graph. Actually, mas maganda yan. Tingnan nyo yung detalye ng graph sa ibang parte. Hindi lang yung values ng settling value ang titingnan natin. Tingnan nyo rin yung mga values dito. Kasi baka mamaya, sabihin natin pareho nga siya settling value, magkakaiba naman pala sila ng value dito, kahit pareho sila ng scale. So, iba pa rin yun. Okay, so, ganun tayo dapat titingin ng graph. Wag masyadong biglang magko-conclude na pareho siya o ano. Tingnan nyo muna kung pareho nga talaga. Pero in this case, since pareho naman siya ng scale, and I would guarantee you na parehong-pareho yung graph na yan. Okay, kahit na magkaiba yung ginamit ko para mag-generate niyan. Okay, this one is done in Scilab, this one is done in MATLAB. Okay, I guarantee you na pareho yan. Okay, so therefore, we can say na kahit na kinuha niyo siya using the model, okay, or using the expression itself, okay, then we arrive at the same response, and therefore that increases our confidence with this answer. That should increase our confidence in this answer. Okay? Is that clear? Okay. Now, let us now proceed with transfer function for electrical networks. Okay? And obtaining this transfer function in electrical networks. Okay. I actually have divided this entire lesson into two. Okay. The first one deals with passive networks. Okay. The second one deals with op-amps. Okay. Basta yung second one yan is about op-amps. Okay. Now, ano nga ba yung passive network? I know baka nadaanan niyo ito before, pero just as the same, i-explain ko na rin kahit konti. Actually, meron tayong dalawang type ng components. Okay? And if these components are used in a network, then that network becomes that characteristic of the component. So, meron tayong tinatawag na passive component. Okay? Passive component. Or passive devices, para mas we have passive devices at saka active devices. Okay? Yung active devices, ito, uunahin ko yung define yung active devices para mas ma-differentiate nyo siya. Yung active devices, these are devices that use their own power supply. So aside from merong supply yung circuit, yung mga active devices na to within the circuit has their own power supply. Ang mga example niyan is transistor. Okay, whether it's a BJT or FET. Okay, active device ang isang transistor. Another one is op-amp. Okay, mga active devices. Because when you actually, kung nakagamit na kayo ng op-amp o nakagamit na kayo ng transistor, op-amp na lang. Kung nakagamit na kayo ng op-amp, bukod sa meron siyang dalawang terminals, the inverting and the non-inverting terminal, meron pa yung supply. Maglalagay pa kayo ng supply dyan. Bukod pa yan sa supply ng circuit nyo. Okay, meron siya rin yung supply. Plus or minus, plus 5 volts saka negative 5 volts. Okay. Kailangan niya kasi yun para makapag-operate siya ng purpose niya. Kasi nga, this being a semiconductor device, kailangan niya ng power supply talaga pagka mag-ooperate siya. Same thing with transistor. Transistor uses power supply para i-bias niya yung sarili niya. Para mapunta siya sa isang operating region or operating point where it is intended to use. Okay, so either you use that you use that, for example sa case ng BJT, tatlo kasi yung operating modes ng BJT. Whether it's active, cut off, or saturation. Okay? So, para mailagay nyo yung BJT sa isa sa mga state na yan, saturation. Okay. Para mailagay niyo yung BJT para sa isa sa mga state na yan, you need to bias the transistor. And for you to bias the transistor, you need a power supply. Okay. So para mag-operate yung mga active devices niyo, they need power supply. Yung passive device, yun ang hindi kailangan ng power supply. Mag-ooperate yung component na yun without a power supply. Bukod lang sa supply ng circuit. Ibig sabihin, kahit siya lang, okay, ang inaasahan niya lang ay yung power supply ng circuit. Okay na siya doon. Example niyan ay resistor, capacitor, and inductor. These are passive devices. So if these things or if these components are used in a network and them alone, okay, walang involvement ng active device, okay, that network is considered to be a passive network. Okay? Pero if your network uses at least one of these things, then that network is considered to be an active network. Okay? So, I hope this is clear to you para alam niyo rin kung bakit passive yung tawag diyan. Okay? And again, as stated, meron tayong components ng passive network niyo. So, these three. Okay. I think merong mas detalyadong discussion dito yung recorded lecture last time. Yung recorded lecture that I assigned you to watch. Okay. Pero ito medyo i-shortcut ng konti. When we determine the transfer function of these electrical networks, we will use mga circuit theorems. KVL, KCL, at saka Ohm's law. Gagamitin natin yung mga yan. Okay, we will use these tools, okay, or these analysis tools. Okay. Pero bago kayo magsimulang gumamit ng kahit isa diyan, okay. Ang gawin niyo muna sa circuit niyo is kunin niyo yung kanyang Laplace transform. Okay, i-quote and quote ko 'yun. We say that we Laplace transform the circuit. Okay. Wala naman talaga tayong ganung operation, but for our purpose, para mas magkaintindihan tayo, that means gagamitin yung term na yan. We Laplace transform the circuit itself. Anong ibig sabihin nun? Ibig sabihin nun, dito. Kung ito yung circuit niyo, if this is your circuit, what you do is you replace yung mga quantities niyo like V of t, I of t, BC of t. Kunin niyo yung Laplace transform niyan. So yung Laplace transform ng V of t is V of s. Yung Laplace transform ng I of t is I of s. Okay? I of s. Yung Laplace transform ng BC of t is BC of s. Okay? So, yan yung unang step. Ngayon, pagkatapos na kayo dyan sa mga quantities na yan, let's go to your components. Okay? Itong L, itong R, at saka itong C, these are called parameters of your circuit. Okay. So, yung L, yung value ng L, okay, L represents a certain value. It represents inductance. Okay? So, this is a particular value na na pinag-uusapan natin. So, that's L. Ganun din yung R at saka ganun din yung C. Okay, so tawag natin collectively this constants, basically they are constants eh. Okay. This constants in your circuit, okay, is called parameter. Are called parameters. Okay, these are parameters of your circuit. Okay. Now, what we need to do is to change these parameters in change this or express this these parameters in terms of what they are in Laplace transform domain. And that means we are taking their impedances. So kukunin natin yung impedances nitong mga to, nung inductor, nung resistor, saka nung capacitor. And how do we determine that? Andito yan sa table. Okay? Ito yung mga impedances ng component nyo. So therefore, yung impedance ng capacitor sa Laplace transform domain is 1 over Cs, while yung resistor is R, tapos yung inductor is Ls. Okay, then we get the impedances of this. So the impedance of this is Ls, the impedance of this is R, and the impedance of this is 1 over CS. Okay? So, yan yung first few steps nung circuit analysis natin. Okay. Now, you proceed as how you would proceed normally. Okay. Kunwari ngayon, walang kakaiba sa circuit niyo. There is nothing wrong, there is nothing different with your circuit. Just proceed as intended. For example, in this case, ang pinapahanap sa akin ay what we are trying to find here is the transfer function relating the capacitor voltage to the input voltage. So essentially, what is being asked of us is to find VC of S over VS. Okay? Yan yung pinapahanap sa atin. Now, for us to be able to find this ratio, we first have to find what is VC. Siyempre, ito yung kailangan nyo munang isolve. Okay? And then, baka later on, madali nang hanapin yung ratio na yan. Okay? The resulting expression for VC might lend itself away to be able to find this entire ratio. Pero ang concentration nyo muna is to find this VC. Okay? And to find this VC, okay, so again magsosolve kasi ako. So instead of actually writing VC of S, I'll write this first as VC. Pero ang understanding natin, this is still VC that is dependent on the variable S. Kaya VC of S pa rin yung original niyan. I'll just drop the of S here. So VC, okay. So hanapin natin yung VC. Now, meron kayong maraming methods para hanapin yan. Pero seeing that the circuit is series, the circuit is in series configuration, then I can use voltage divider theorem for this one. So gamitan siya ng voltage divider theorem. Kasi nga series yan Ibig sabihin nun, the voltage is proportionally divided among the components. Okay? So doon ko gagamitin yung voltage divider theorem. So yung voltage divider theorem starts with the total voltage, which is V. Okay, ito, yung total voltage yan. Multiplied to the ratio, kasi nga proportional nga yung voltage in each component dun sa impedance. Okay, so therefore, kunin natin yung impedance nung capacitor nyo, which is 1 over CS as the numerator. Para maging proportional yung VC, okay, dun sa impedance niya. Okay, over to sa total impedance ng circuit nyo, which is LS plus R plus 1 over CS. Okay. Na-recall yung voltage divider? Okay, ito yung sabi ko kanina that the expression for VC might lend itself away, okay, for us to find the entire VC over V ratio. Kasi ito, pag dinivide ko yung both sides by V, the left side becomes VC over V. Ito na yung ratio na hinahanap ko mismo. Okay, yan yung ratio na hinahanap ko mismo. The right side becomes simply 1 over CS over LS plus R plus 1 over CS. So, basically, ito din yung hinahanap ko. What I just need to do is to simplify this. Okay, isi-simplify ko to. Kasi may mga complex fraction pa kasi siya So, I would just like to make this a simple fraction. A simple fraction o a simple rational expression for two polynomials. Ibig sabihin, gusto kong gawin tong ratio of two polynomials. So, in that case, ang gawin natin is i-multiply natin yung ratio na yan by CS. Okay? Essentially, kaya CS para ma-eliminate yung fraction na yung denominator na to sa isa sa mga terms. Okay, so that's one way that you can start thinking about simplifying expressions such as this one. Hanapin niyo yung kung aling fraction or aling factor ang mag-eliminate ng lahat ng fraction sa denominator. That's where you start. So in this case, ito yung fraction ng denominator. To eliminate this fraction, multiply ko yan ng CS para maging 1 yan. And then, i-multiply ko itong CS na to sa lahat ng terms, pati sa numerator. So this becomes now 1. Kasi CS times 1 over CS yan. So that is 1. Over, that is LCS square plus RCS plus 1. Okay? Okay, that's 1. Okay? So, ayan. Ay, nabura. Ngayon, lastly, if it is convenient for us or for you. Ang ultimate aim din kasi ng finding the transfer function. Okay. So this is now g of s, no? Which is bc of s over b of s. The ultimate objective in expressing the system's transfer function is that yung denominator nyo, yung leading coefficient ng denominator nyo should be 1. Pag sinabi yung leading coefficient denominator, yung coefficient ng pinakamataas na degree dun sa polynomial ng denominator. So, I'm talking about this term. Okay? S squared kasi yung pinakamataas na na polynomial. Okay? So, ang gusto sana natin is that yung coefficient nitong S squared dapat 1. Okay? Dito, kaya naman siyang gawin. That is by dividing the denominator terms with LC. Okay, pag dinivide ko itong mga terms na to with LC, yung coefficient ng S squared magiging 1. Okay, pero if I do that in the denominator, you also do that in the numerator. Okay, so the numerator then becomes 1 over LC. Okay, and then the denominator becomes S squared plus R over L times S plus 1 over LC. So ito yung nahanap sana nating transfer function. Okay? Do I make myself clear here? Now, we proceed now with networks having multiple loops. So simulan muna natin sa 2. Okay. Ang natin dito is that in determining transfer function for electrical networks, no matter how many loops they would have, i-fix na lang natin yung solution natin sa tinatawag nating mesh analysis. Okay? I mean, maraming ways para ma-solve nyo or para ma-solve nyo yung networks kagaya nito na given sa board. Pero ang gusto natin kasing gawin is gumawa tayo ng parang universal method of generating equations para sa para sa circuit niyo. Okay? So, yun yung gusto natin i-develop dito. Now, kung medyo na master niyo ang paghahanap ng mesh equations using KVL, okay? Merong pattern yun na sinusundan. Okay? And that pattern actually boils down here. Yung pattern na yon, pwede niyo i-summarize sa dito sa expression na to. So let me help you interpret this one. Kopyahin nga natin to. Ayan. Hindi cut. Joke lang, hindi cut. Ayaw na bumalik. Dapat copy. Ayan, copy natin siya. Let us copy this here. Pwede ba itong yun? In order. Send backward. Yun nga. Ganun lang. Ito lang. Ganun din eh. Okay, so ganito. Kung yung circuit nyo, merong dalawang loops. Okay? Meron dalawang current na tatakbo sa ano nyo. Okay? Meron dalawang current na tatakbo dun sa loops niyo. Okay. For example, in this case, meron kayong dalawang loops. Say this one is the first loop or loop 1. Okay. And this the other loop is called loop 2. Okay. Take note lang that I1 okay, flows through loop 1. Okay, while I2 is at loop 2. Okay? And by the way, again, ang first step nito, yung VT magiging VS, yung I1T magiging I1S, yung I2T magiging I2S, okay? Yung VC of T magiging VC of S, okay? Then R1 is R1 sa impedance, R2 is R2 in impedance, okay? L is LS, okay? And C is 1 over CS. Okay, that's the first step. Okay, pero we take note that I1 flows at loop 1 and I2 flows at loop 2. Okay, this is how we generate now mesh equations. Una natin tignan is, for example, yung loop 1. Okay? Since, tignan nyo sa expression na to, yung first equation na to pertains to the equation at loop 1. So ito, this one is the equation for loop 1. Ito naman for loop 2. And again, take note that loop 1 has I1 as its current. Okay? Ngayon, pagka ganun, ang rule doon is that yung impedances that you need to multiply to I1, okay, or to the current flowing in that loop should be positive. Now, the rest of the impedances that to be used would be negative. Again, kung I1 yung nasa loop 1, okay, yung impedances na dadaanan ng current na to is considered positive. Okay? While these other impedances, okay, is assigned as negative. Actually, all other impedances na may ko-consider nyo should be negative. Okay, nanggagaling yan actually dun sa kung maalala nyo, pag ito yung impedance at ito yung I1, tapos ito yung I2, kasi dalawang current yung dumaan sa kanya. Ang ginagawa nyo dyan, mina-minus nyo yan. Ang ginagawa nyo dyan, that becomes I1 minus I2 times, for example, R. Ganyan yung ginagawa nyo sa mesh equations. Okay? Kaya nagiging negative yung And what is this What is this impedances? These impedances are common to the two meshes. Ibig sabihin, these are impedances that is passed by, ang pangit ng term ko, yung dadaanan nung I1 at saka ng I2. Yung katulad nga ng situation na to. Pag dinaanan ni I1 tsaka ni I2 ng parehas sa dinaanan ng I1 tsaka I2 yung impedance na yon, then we consider that impedance to be common to both I1 and I2. Okay, and all of those impedances, all of those common impedances should carry a negative sign. So ang positive lang dito ay yung impedances na I1 lang or exclusive lang na I1 ang dumadaan. Okay? Is that clear? Okay. So in this case, sa case ng circuit natin ito, ganito mangyayari dyan. At loop 1, okay, which is in which I1 flows. Okay? Pwede natin kunin lahat pwede natin kunin yung sum of impedances that is passed by. Ang pangit talaga ng term na yan. That is passed by I1. Okay, wala akong message term sa dadaanan eh. Okay. That is passed by the I1. Okay? So, in that case, yung mga dadaanan niyang impedances ay ito, R1 at saka ito, LS. So, we find their sum. R1 plus LS. R1 plus LS. Then we multiply it by I1. Okay, again, this would carry a positive sign. Kasi nga, I1 yung bida dito sa loop 1 na to. Okay? Now, the next part of the equation should be negative now. Kasi that means na ang multiplier doon ay hindi na I1. Okay? Ibang current na yung multiplier. So, negative na yung impedances na magagaling doon. And that impedances should be those impedances that is passed by, that nadadaanan pareho ng I1 at saka ng in this case I2. So, yung impedance na yun is itong LS na to. Kasi parehong itong LS na to, parehong dadaanan niya ng I1 at saka ng I2. Yun yung sabi natin common impedance between I1 and I2. Okay? So, that common impedance is LS. And that LS would carry a negative sign. Kasi nga ito na yung positive. And that LS also is to be multiplied by the other current, which is I2. Okay? Now, the right side of this equation, the right side of that equation should be the sum of applied voltages around mesh 1 or loop 1. So, tingnan natin kung merong EMF na connected sa loop 1, which in this case meron. And that is this EMF. So, therefore, yung right side nito is simply V of S or V. Okay? Maliwanag ba to? Okay. In the case naman of loop 2, where I2 flows, okay, yung current I1 ngayon, yung current I1, kasi para consistent tayo na ang first, ang equation na sinusulat, ang term na sinusulat ko first ay yung para sa I1. Okay. Yung I1 na to, means ito yung common, kasi nga ang bidang current sa loop 2 is I2. So therefore, itong I1, ang lalagay nyo dyan is yung common between I1 and I2. And in that case, that is also LS. And again, this is negative. Kasi ang magpa-positive lang ay lahat ng impedances na dadaanan directly ng I2. Which in this case ay R2 plus LS plus 1 over CS times I2. And then, yung right side ng equation to again is sum of voltages or sum of EMFs impressed upon loop 2. Kung titingnan natin, wala namang power supply or wala namang voltage supply dito sa loop 2. So therefore, walang EMF or walang applied EMF dyan. So therefore, your right side here becomes 0. Okay? Now, you have two loops. You have two loop equations. You now have a complete set of equations in order for you to solve this circuit. Meron ka ng equations to solve this circuit. Okay? Now, and I hope you'd be able to practice that technique. Itong technique na to. And also to be able to extend that to multiple loops. Okay? Essentially, yung rules naman na gagamitin nyo, for example, mayroong 3 loops. Okay? Pareho lang naman. It's just that magkakaroon kayo ng tatlong currents kasi tatlong loops yun eh. So, magkakaroon kayo ng tatlong current. I1, I2, I3. Okay? So, ayun. So, sa loop 1, positive yung I1, negative to. Kung yung I1 nasa loop 1. Okay? Sa loop 2, kung ang current sa loop 2 ay I2, di negative yung I1, positive yung I2, negative yung I3. Sa loop 3 naman, okay, kung ang current sa loop 3 ay I3, then negative yung I1, negative yung I2, positive yung I3. Okay? Tapos, dito sa loop 1, ang hahanapin nyo dyan, okay, what you would find in dito para sa I1 ay sum of impedances. Sum of impedances. Okay? While dito sa I2 is the sum of common impedances. Eraser muna. Ayan. Ang hahanapin nyo para sa I2 or yung i-multiply sa I2 ay yung sum of common impedances. Of course, between I2 and I1. Okay? Sana nagigets nyo yung nagigets nyo yung pattern. Ito naman, ang kukunin nyo dito is yung sum of common impedances between I3 and I1. Okay, so that should complete your first equation. Sa second equation nyo naman, dito nyo hahanapin yung sum of impedances. Okay, dito common, dito common. Okay, dito common sa I1 tsaka I2 ha. Ito naman, yung common na to, I2 tsaka I3. Okay? Now, para medyo mas madali yung trabaho nyo, papansinin nyo na dapat ito kasi yung common dito, common dyan ay I1 at saka I3. Okay? Common dyan yung I1 tsaka I3. Dito, ang common dito is also I1 at saka I3. So, dapat ito, yung expression dito, at saka yung expression dito, dapat pareho lang. Same thing with for example, ito, at saka, ang common dito ay I2 at saka I3. Okay? Saan natin pa makikita to? Dito, no? Ang common din dito is I2 at saka I3. So, ito at saka ito, pareho lang. Tapos ito at saka to, pareho lang. Okay? In the end, dapat this should result to what we call asymmetric symmetric matrix. Okay? Para ma-check nyo siya. This should result to a symmetric matrix. Pag sinabi nyo ang matrix ay symmetric, pag transpose nyo yan, yun din yung lalabas. Yung original matrix din. Okay? Halimbawa, to? 1, 2, 3, 2, 4, 6. Okay? Tapos 3, 6, 7. Halimbawa. Yan, symmetric matrix yan. Bakit? I-transpose natin siya. Pag transpose nyo yan, ganito ang mangyayari. Itong 1, 2, 3 na to, isusulat kong pa ganito. So that becomes 1, 2, 3. Itong 2, 4, 6 na to, susulat ko dito. 2, 4, 6. Tapos itong 3, 6, 7, okay, susulat ko this way. 3, 6, 7. So di ba pareho lang sila? Okay? So ito is considered to be symmetric matrix. Ganito yung mangyayari dyan. Pag nakompleto nyo to, ganito yung mangyayari dyan. Okay, check nyo to. Itong example 2.7. Yan, check nyo yan. Pansinin nyo na ito, pareho dito. Ito, pareho dito. And ito, hindi yan. Ito, pareho dito. Okay. So, I hope meron meron akong mga nalinaw na points na baka hindi nyo masyadong na-pick up dun sa recorded lecture. And ayun, medyo baka meron kayong mga points that are not really clear if you have watched that video. Okay, so I hope may mga nalinawan ako mga points dyan. And also, since ang expectation ko nga is that you are watching that video and if you are having problems, I hope that I get to be informed kung nagkakaproblema kayo. And since up until now, wala namang nagsasabi na may problema sila. So, ang assumption ko ay okay lang kayo. Okay. So, I hope na na ituloy niyo yung panonood ng videos na 'yon para matapos niyo tong chapter na to, yung topic 2. So that you get to be finished in chapter 2. Okay, kasi next week, we'll proceed with topic 3. Okay, again, ang expectation ko at this point, ang expectation ko at this point is matatapos nyo yung aralin to using the provided recorded lecture to you. Okay, anyway, kung papansin nyo naman, pareho lang naman halos dahil sa video, hindi naman ako nakikipag-interact sa inyo. Okay, so parang wala rin naman tayong interaction. So, yung experience sa video, tsaka yung experience dito, halos pareho lang naman. Okay. So, ayun. Kaya if you're not yet done with the video, okay, please do complete them. Okay, sana preferably next week. Okay, kasi that is what our asynchronous learnings are for. Okay, kaya nagpo-provide ng recorded lecture sa inyo. It's because mayroon ngang pagkakataon that we have to shift to asynchronous learning. And that asynchronous learning is where you give time para panoorin yung video at saka gawin yung activities assigned to you. So I hope na yun ang ginagawa nyo. And hindi yung thinking that pag sinabing asynchronous meeting, walang pasok. Okay, hindi tayo ganun. Okay. Baka ganun yung iniisip niyo. Okay, so ayun, next week we'll proceed with topic 3. Okay. And sa una, mag-a-assign muna ako ng recorded lecture sa inyo kasi may recorded lecture din naman ako para dito. So mag-a-assign ako ng recorded lecture for you to watch. Okay. So and then magsi-synchronous meeting tayo just to discuss some of the things that I would like to discuss with you. Okay? So, again kung nagkakaproblema kayo dun sa mga lessons dun sa ating mga hindi ko siya nilalagpasan meron kayong mga recorded lecture for that. So, I hope na hindi ganun ang impression niyo is hindi siya nilalagpasan ng topic. Okay? I hope na inaaral niyo siya. Okay. So, pero pag nagkakaproblema kayo, I mean, may problema, hindi kayo malinawan or mayroong malabo for you, just inform me para matingnan natin kung paano siya i-correct. Okay? Is that okay with you? Okay. So, also as a reminder, ang schedule ng quiz natin ay February 3, tama? Course reminders. February 3, malapit na to. Na-assign ko na sa inyo is di ba? Ano ba yung na-assign? Topic 4? Assign na ba sa inyo yung homework 4? Assign na yan. Okay. So, it means, more or less, hanggang dyan yung first quiz natin. Hanggang topic 4. Okay. Kaya yun yung inassign ko na so yung susunod niyan, nasa quiz to na. Okay? So, let's dismiss na kasi overtime na ako ng 2 minutes. I hope to see you on Tuesday. Tingnan ko on Tuesday makakapag-online session tayo. Pero if not, may gagawin pala tayo sa next Friday. May papagawa ko sa inyo sa next Friday, which is baka hindi tayo makapag-lesson ng So, tingnan ko kung makakapag-lesson tayo sa Tuesday. Okay, so ayun, I'll see you next week whether through this or to another way. And again, kung may mga questions kayo, send nyo lang sa akin. Okay? So, sige, tara na. Nagutom na ako. Thank you for attending today.
Thank you, sir.
Okay.
Thank you, sir.
Okay. Basta pag may problema message lang.
Thank you, sir.
Okay.